Good morning to Doctor. I'm Annie Chongren 304934. Today, our group will be presenting our project for BJTNK2033 Production and Operation Management title of Optimizing the Operation of a Manufacturing Company. Production and operation management focus on how organizations effectively transform inputs such as raw materials, labor, and technology into high-quality outputs that meets customer needs. In today's highly competitive manufacturing environment, companies are under constant pressure to reduce costs, improve qualities, and deliver products on time. In this project, we apply key POM concept to analyze the operation of Aquanova Industries Sdn Bhd. A medium-sized Malaysian manufacturer, our analyzing cover the company production process, capacities planning, inventory management, quality control, and supply chain operations. Based on the issue identified, we propose practical improvement to enhance effectively productivity and long-term competitiveness. First, let us introduce about our company. Aquanova Industries Sdn Bhd is a medium-sized manufacturing company established in 2012 and located in Shah Alam, Selangor. The company specializes in producing reusable and eco-friendly water bottles to support sustainable hydration solutions. Aquanova manufactures a range of products including PET plastic bottles, stainless steel thermos bottles, and smart hydration products. The company operates a modern manufacturing facilities with approximately 250 employees using advanced technologies such as injection molding and blow molding. The company emphasizes innovative, sustainability, quality craftsmanship, and customer well-being. Its mission is not only to provide reliable hydration products but also to contribute to environmental protection. As market demand increases and competition intensifies, Aquanova must consistently improve its operation to remain competitive. Now, let's move to next slide. Current operations challenge. Despite having strong production capabilities, Aquanova faced several operations challenges that affect efficiencies and performance. Firstly, the assembly and packaging departments are overloaded, which causes production delay and late customer orders. In contrast, the quality control department experienced idle time, indicating an unbalanced workload across departments. Secondly, the company faced inventory management problems, including overstocking of PET resins and frequent stockouts of essential packing materials such as label and cartons. This results in higher holding costs, production stoppages, and emergency purchase. In addition, Aquanova relies heavily on a limited number of suppliers, leading to supplies deliver delays that distract production schedule. Poor factory layout also causes unnecessary workers' movement, increasing time wasted and reducing productivity. Overall, this challenge creates bottlenecks, increased costs, and limit the company's ability to respond efficiently to customer demand.
Overview of current production process. Raw material receiving. The PET pellet are received, inspected for quality and stored to avoid contamination. Material drying and preparation. The PET pellets are dried to remove moisture and prevent product defected. Injection blowing. PET are melt and mold into preform. Blow molding. The PET pellet are blown into the bottle shape. Assembly. Cap and closure are attached to the bottle to ensure proper sealing. Quality control. Bottles are checked for defect, leakage, and correct dimension. Finishing and branding. Finishing. Approved bottle receive label and branding for market readiness. Packaging and storage. Bottles are packed into carton to protect them during handling and transport. The finished product are stored in a clean and dry area before shipment. Delivery. Packaged bottles are transported to distributor or customer. Capacity planning. Quality control department. First inspection process. High idle time due to the low workload. Assembly department. Near full capacity operating near full capacity. Limited flexibility during peak demands. Packaging and finishing department. Overloaded department. Main production of the bottlenecks. The result, work in progress is built up and delay customer order. Capacity issue identified. The main capacity issue identified are uneven production flow, overloaded assembly and packaging department, and underutilized quality control. This bottleneck increase waiting time, cost of WIP or work in progress build up, and reduce the overall productivity of the company. Capacity improvement recommendation. To improve capacity, the company should add worker or machine in assembly and packaging. Extra shift can be introduced during the peak demand, while quality control staff can support other tasks during ideal time. Applying a correct Kanban pull system and line balancing will help improve the production flow.
Hello, my name is Moizuddin bin Muhammad Noor. My metric number is 304492. I would like to explain how a water bottle manufacturing company manage its inventory and the challenge it currently faces. The company handles several categories of inventory that are essential for daily operations. First, there are raw materials such as PET resins, bottle caps, labels, and carton box. These materials are stored in the warehouse before being used in production. For example, large sacks of PET resin pellets are kept for the bottle molding process, while thousands of bottle caps are prepared and stored for use on the assembly line. Next, the company has work in progress or WIP inventory. This includes bottle performs and half-finished bottles that are still waiting for process such as labeling or packaging. The third category is finished goods. These are bottles that have completed all production stage, pass quality inspection and are packed into cartons ready for delivery to customers. In addition, the company also stores maintenance, repair and operation items or MRO items. These include machine, lubricants and cleaning chemicals which are necessary to maintain and ensure the smooth operation of production equipment. Currently, the company uses a simple, non-digital inventory management system. Staff manually estimate when materials needs to be reordered without using systematic calculation for order quantities or reorder levels. Most decisions are based on visual inspection of stock labels. Although this method is easy to implement, it leads to inconsistencies and inefficiencies in the overall production process, such as overstocking, stock shortage, and delays in production. Next, I would like to talk about inventory problems. Despite having sufficient inventory, the company faces several serious inventory related issues that disrupt productions, increase operating costs, and reduce overall efficiency. One major problem is the overstocking of PET resins. Since the company relies on estimation rather than actual demand data, large quantity of PET resin are ordered even during periods of low production. As a result, warehouse become overcrowded, leading to higher inventory carrying costs such as storage, handling, and insurance. In addition, excessive stock makes it difficult for employees to properly rotate inventory, causing older PET resins to remain unused for long periods. On the other hand, the company frequently experiences stockouts of essential packaging materials, especially labels and carton box. Because there is no established reorder point system, the packaging team often only realize that stock has run out when it is already needed. The situation causes production stoppage and force the company to place emergency orders, which are more expensive and can delay customer deliveries. In one instance, Production had to be stopped for 2 days while waiting for an urgent shipment of labels. Another issue is the lack of coordination between the production and packaging departments. The production team may continue molding bottles even when the packaging department has run out of label or caps. This leads to a large buildup of work in progress inventory in the warehouse. For example, thousands of molded bottles were once left waiting for labels, occupying valuable storage space and increasing the risk of product damage. Lastly, the company face supplier reliability issues, particularly for bottle caps and labels. Since the company depends on only a limited number of suppliers, any delay directly affects productions. For instance, a 3-day delay from a bottle cap supplier results in a complete shutdown of the assembly line because no alternative supplier was available. Overall, these inventory issues highlight the need for a more systematic and coordinated inventory management approach to ensure smoother operations and improve efficiency. To address the inventory problems faced by the company, a more structured and data-driven inventory management system should be implemented. Specifically, the company can adopt the economy or order quantity EOQ model and ABC classification. These strategies will improve inventory accuracy, reduce operating costs, and ensure smoother and more efficient production process. Economic order quantity. The economic order quantity or EOQ is an important inventory management tool that helps a company determine the optimal quantity of items to order while minimizing total inventory costs. These costs include ordering costs, holding or carrying costs, and shortage costs. By applying the EOQ model, the company can calculate the most cost-efficient order size for essential materials such as PET resins, bottle caps, and labels. EOQ works by balancing ordering costs with carrying costs, which helps prevent both over-ordering and under-ordering. For example, if the company requires 150,000 bottle caps per year, the EOQ model can be used to calculate the optimal order quantity, perhaps around 12,000 caps per order. This approach minimizes storage costs while ensuring a continuous and reliable supply for production. ABC classification. ABC, cal- ABC classification is an inventory management technique that categorizes inventory items based on their importance and value to the business. This method helps the company prioritize inventory control efforts more effectively. Under ABC analysis, Class A items such as PET resin and bottle caps are high value and critical to production. These items should be monitored closely and reviewed frequently. Class B items, including labels and carton box, are moderately important and can be monitored on a regular monthly basis. Class C items such as cleaning materials and other MRO supplies are low value items and can be checked less frequently. For example, PET resin may account for up to 70% of the company total inventory value while MRO items may represent only about 5%. Therefore, it will be inefficient to manage both categories with the same level of control. By implementing EOQ and ABC classification together, the company can significantly improve inventory control, reduce costs, and enhance overall operational efficiency.
Greetings to our lecturer, Dr. Shahzid Iqbal. My name is description and Italian text number 304X61. So I will talk about the current issue in quality control. First, QC, quality control. Inspection done too late. The inspection are normally done after the product has been completely assembled, which make the method reactive. Consequently, defects are identified at the late stage, which increases the rate of defect and wastage of the material. Secondly, heavy reliance on visual inspection. Such approach is based on human judgment and may lead to error quite easily, particularly when verifying bottle size, thread accuracy, and small or micro defects. Third, inconsistent SOPs. The other problem is the absence of SOP. The various QC inspectors are likely to adhere to different inspection procedures, thereby leading to inconsistency in the inspection outcome. Moreover, most measurements are performed manually without use of appropriate measuring tools. This adds the risk of human error and lower the accuracy of measurement. Finally, QC capacity underutilized. Inspection operations are also less time consuming than the production process, with QC personnel having to spend time in idleness and lack of capacity balance. Next, propose quality control improvement. To begin with, the company ought to introduce total quality management (TQM). TQM promotes a preventative model in which quality is incorporated in each production step. It is not only the QC department, but all employees and its aim at continuous improvement and teamwork. Second, uniform standard operating procedures ought to be created. These SOPs will offer step-by-step inspection procedure which will ensure that all the QC staff use the same procedure in all shifts. This will decrease subjectivity and enhance consistency. Third, the company ought to present statistical sampling with acceptable quality level or AQL. A systematic sampling strategy enables inspection to be made in the term of volume of production and tolerance of defects, as opposed to random sampling. These outcome of these enhancements are early defects, less rework, and more consistent product quality. Thank you.
Good day to our lecturer, Dr. Shajar Iqbal. My name is Chan Hong An, metric number 304471. So now I will be presenting Task 5 Supply Chain Management. Supply chain management is very important in the production of water bottles because it affects how quickly raw materials are obtained and how smoothly production runs. Currently, the company is facing several supply chain problems that slow down production. One major issue is late delivery from suppliers. Since the company depends on suppliers for materials such as plastic resin, stainless steel, and packaging, any delay stops production and causes order backlogs, which may lead to customer dissatisfaction. Another problem is the company does not evaluate supplier performance. There is no system to measure delivery speed, quality, or pricing, which means poor performing suppliers may still be used. In addition, the company is over-dependent on single suppliers, which is risky if one supplier experiences delays or shortage. The company also relies on manual ordering methods such as phone call and message. This can lead to errors, poor stock planning, and last-time orders that are costly and unreliable. To improve the supply chain, the company should first implement a supplier evaluation system to identify reliable suppliers and build long-term partnership. Second, using local suppliers can reduce delivery time and the transportation costs. The company should also adopt vendor-managed inventory, where suppliers monitor stock levels and refill materials automatically. In addition, Switching to an electronic procurement system can reduce errors and improve efficiency. Finally, using a dual sourcing strategy will reduce the risk of production delays. In conclusion, improving the supply chain will make production faster, more reliable, and more cost-effective, helping the company meet customer demand and stay competitive. Thank you.
My name is Angie Parachak and my matrix number is 304958. Next, I will explain the cost and time reduction strategies proposed for Aquanova Industries. Firstly, preventive maintenance is introduced to reduce machine downtime, especially at the SPM stations, which are major bottlenecks. Regular inspections and scheduled maintenance help prevent unexpected breakdown and ensure smoother production flow. Secondly, layout optimization is recommended to reduce unnecessary worker movement. By redesigning the factory into a more linear workflow, processing time can be shortened and worker efficiency improved. Thirdly, partial automation is proposed for repetitive tasks such as perform feeding and packaging. This reduces manual labor, shortens cycle time, and improves consistency at a lower cost compared to a full automation. In addition, lean manufacturing techniques such as 5S and Kaizen are applied to eliminate waste, improve organization, and reduce delays. Inventory optimization using EOQ and JIT system will also reduces excess inventory and prevent material shortage, lowering holding costs. Finally, workload balancing and batch scheduling will help minimize bottlenecks between departments and increase overall production efficiency. Overall, these strategies reduce costs, save time, and improve productivity across the entire production process.
By implementing the proposal's operational improvement, Aquanova can achieve significant benefit. Firstly, productivity and outputs are expected to increase by 20 to 30% through improved capacities planning, reduced bottlenecks, and better workforce balance. Secondly, products quality will improve due to standardizing operating procedures, better quality control system, and preventive maintenance. This will reduce defect, rework, and customer complaints. Thirdly, the company will experience lower operational costs as a result of reducing machine downtime, lower inventory holding costs through EOQ and JIT system, and less overtime work. Furthermore, improvement in supply chain management such as dual sourcing and supplies evaluations will create a more reliable and stable supply chain, reducing the risk of production disruptions. Lastly, improved layout design and patterns automations will enhance worker efficiency, safety, and morale, contributing to a more productive working environment. In conclusion, Aquanova Industries Sdn Bhd have strong manufacturing potential, but its currency affected by inefficiencies in capacities utilizations, inventory management, quality control, and supply chain operations. Through the application of productions and operation management principles, this project has identified practical and achievable solutions to address this issue. The proposal's improvement focus on reducing waste, balancing workloads, improving quality consistency, and lowering operation costs. If implemented effectively, this strategy will enable Aquanova to operate more effectively, meet customer demands more reliable, and strengthens its competitive positions in the markets. This project demonstrates how theoretical POM concept can be successfully applied to solve real-world manufacturing challenge. Thank you. That's all from our group.